Don't worry, back row, you'll get it here in a moment. Louisa tooted and the smell will get back there to you guys. I'm teasing, she didn't. You're like, what? Okay. Natural killer cells. Now when we talk about the body and we talk about our immune system, the one thing that we have to think about is that it is happening 24 hours a day, 7 days a week for the rest of your life. It is occurring right now. In fact, your immune system is fighting off things that are occurring in you right now. And for the biggest majority of it, like huge amount of it, you never know it's happening. Never know it's happening. Never. And here's what's even better. If you have memory cells, if you have cells that have already been exposed and you have memory cells, the chances are you're going to do this. Oh, I think I'm getting sick. And then you wake up the next morning and you're like, wow, I feel great. That's because your memory cells were so fast and they were already there, they were already exposed to it, that literally you felt some minor symptoms, and that was it. It was done. Okay? Now, I've already talked to you guys about how fast a virus or bacteria can go through you and how slow it can go through you. The faster it is, the more deadly it is. The slower it is, the less deadly it is. Notice I said less deadly because it can still be deadly. But we're at a point right now, antibody-mediated immunity was part of B cells, okay? And natural killer cells, okay, make up to 5 to 10% of circulating lymphocytes, okay, responsible for immunological surveillance. Let me make sure I say my words properly. They attack foreign cells, virus, infected cells, and cancer cells. Now, they literally can go up to any cell in our body and say, yo, Roberta, are you good? No, I know you belong in the class. You're not good? And done. That's what they can do. They can choose to ignore the fact that you belong in the body and attack you anyways. Okay? What does this mean? Never let monkeys eat bananas, so never? No. Neutrophil? All right, so these are the first ones, most abundant, they're always there. These guys? Lymphocytes.
2% or something?
Not percentage, what are they?
Oh.
B and T cells. And that's what we're studying right now. Okay? Monocytes. Eosinophils, we already know, parasites. Basophils, histamine. Okay, and then these guys here, remember, they're first on the scene. They're going to sound the alarm. They're going to sound the alarm to what's going on. Now, all of these are the immune system. All of them. They're all going to have a part in the immune system. The two that are going to make up our defense against viruses and bacteria are the B and T cells. The two that are going to make up the defense. Now, we already know that T has a whole run of them, right? You guys remember this? Cytotoxic T, memory T, helper T, suppressor T, reg T, and then B cell, okay, immunoglobulins, antibodies, natural killer cells. Well, right there. There they are. And those are the ones that say, you know what? Now, I use Roberta as an example, but a macrophage will do this. Oh, yeah, the sniffles? Okay, whatever. It won't do anything. Our B and T cells, on the other hand, guess what? They're going to attack. They're going to go after it. Now, B cells don't do hand-to-hand. They do what? Yeah, antibodies, they're going to glom onto you. They're going to make it very hard for you, okay? So here you go, subdivided into classes of lymphocytes, T cells, cytotoxic T, helper T, suppressor T, and memory. Memory is what's left over. Now you do not have any memory until you're exposed to it. Let me say that one more time. You do not have a memory cell until you are exposed to it. Okay, so Mimi right now, if she's never had influenza B, which is the flu, she has no memory cells for it whatsoever. That means she has to activate her T cells and her B cells, and she has to fight it off. Now, if she's been exposed to it, then she has memory cells, and she has lots of them, and they're fast. So a memory cell is this. How many people in here have been to Disneyland? Raise your hand. Okay. You just raised your hand because you were like, I want to go? Like, it's the happiest place on earth. Me. Okay, so the people that have been to Disneyland can go to Disneyland, navigate, understand, have fun. It's Disneyland. The people who have not been to Disneyland have to discover Disneyland. They have to figure out what a fast pass is and how to get in line ahead of time and how to separate out the fast passes for the ones they want to do and not to do, when to eat and when not to eat. Okay, and I know you're thinking, really? That? Oh yeah. You've got to be strategic when it comes to Disneyland. Okay? A memory cell is a person who has been to Disneyland. Okay? If you've never been to Disneyland, you're a T cell. You just don't have the memory of it. Like, you know it. You want to go to it, but you don't know what it's all about. Okay? So that's what a memory cell is. It's already been activated. It already understands. It has memory of what's going on. It's familiar. But just with that one pathogen. That's why I use Disneyland, because then there's Six Flags, there's Marriott's Great America, right? There's Disney World. Okay? There's tons and tons of different ones. Kennywood. Has anybody been to Kennywood? I'm the only one that's been to Kennywood? Really? Awesome. Yeah, that's so awesome. If you've never been before, Virginia, oh my gosh. One of the largest roller coasters in the United States. 200 feet tall and 85 miles an hour on the drop. It was unbelievable. I went on like 13 times. It was so much fun. Oh yeah. Oh dear. Yeah, and it goes underneath itself and through all of its loops. It has like 7 loops. And it goes through the loops, comes back, and then does them all. So you get to see what you're going through before you get to it. Oh, I did it at night. It was so much fun. So, do I have a memory of it? Yes, I do. Okay? But that's a different cell with a different memory. You'll have some cells in your body that will never, ever, ever get activated. Never. They'll live with you forever, but never be activated. Let me give you an idea. You have a cell that'll actually fight off hepatitis. Okay? It won't win, but it'll fight it off. If you never get it, does that cell ever get activated?
No. When you get the vaccine.
What's that?
The hepatitis vaccine.
If you get the vaccine, it prevents it. Okay? Okay, so that's where we're going. We're focusing on lymphocytes, B and T cells, and what they do. Suppressor, those are the ones that are going to tell you to chill out. Okay? Helper, well, just like they say, helper. They're going to help. They're going to start immune responses. B cells, on the other hand, they're going to differentiate into plasma cells and they're going to secrete antibodies. Okay? And the natural killer cells, well, again, these are the ones that are going to check and balance our own cells. They're actually going to go up to our cells and say, do you really belong here? Are you infected? Because if you are, they'll just attack you. They'll choose to ignore that you belong, and they will attack you. Now, the other class said, oh, is that part of autoimmune? It can be, yeah. Where you have an autoimmune response, where you attack yourself. Okay, it can be. Okay? Lymphocyte distribution, well, tissues maintain different T cells and B cell populations. Lymphocytes wander through tissues, enter blood vessels, lymphatics for transport, can survive for many years, your whole life, without being activated. Now, I do want to say this, they tend not to wander. They tend not to wander. They tend to stay in the lymphatic system. Okay, they will go out into the bloodstream and into tissue, but usually only during some type of infection. Okay, for the most part, they tend not to wander. Yeah, I guess wander is kind of they're not out there in full force type thing. So yeah. Now, production. Lymphopoiesis, well, this goes all the way back to what we were talking about when we were in blood. You guys remember blood and the production of white blood cells? Yeah, so we went through all of that, right? Bone marrow, and then the thymus. Now, the thymus is where you're actually going to go to school. That's where you're going to school. That's where you're going to mature. You're going to go to school. You're going to understand what you're supposed to do. You're going to get tested. You're going to be tested on whether or not you're too aggressive or too passive. Okay? Too aggressive or too passive. If you're too passive and you can't shake hands, you're done. Apoptosis. Dead. Okay? If you're too aggressive, you're done. Apoptosis. We don't want you around. Really? Think about it. Okay? I can't find. You're done. You're useless. Okay? How about this? You're too aggressive. You're done. We want this. Okay, now you can go out and you can check and balance other cells. You can go around and be like, because then you're going to kill your own self. If you're too aggressive, you're going to kill your own self. You're going to go after your own self. Autoimmune. But if you're like this is good, everything's good, you're not too aggressive. So you're going to get a checks and balance. We're going to make sure that cell doesn't go out and kill other cells. And that's going to occur in the thymus. Excuse me. Go ahead. I'm going to get to it. I'm going to get to the checks and balances. You're jumping ahead. Pull back on the reins. Just wander. It's okay? All right? So, lymphoid stem cells, group 1, remains in the bone marrow and develops with help of stromal cells, produces B cells and natural killer cells. Group 2 migrates to the thymus, produces T cells in environment isolated by blood-thymus barrier. So, we're going to split up, okay? We're going to split up, and obviously those B cells, notice it says lymphoid. Oid. What does that mean, oid? Yeah, of the same shape, but not the same thing. So B cells are going to stay in the bone marrow. Let me say that one more time. B, bone marrow. B, bone marrow. B cells are going to stay in the bone marrow. They're going to mature there. T cells are going to go to the thymus. T, thymus. T, thymus. How about that T in thymus? Did you know that the word thymus is spelled with a T? Like T cell? Just saying. Okay, so here you go. Okay, lymphoid stem cells. Wow, interleukin 7. Make a note of that. You're going to see tons and tons and tons and super tons and bucket loads of interleukins. Tons of interleukins, okay? Red bone marrow, natural killer cells, and B cells. Okay, notice it says lymphoid stem cells. Well, that's another one. Notice it's set aside. So in the bone marrow, B cells, natural killer cells. Oh, look at this. Lymphoid stem cell is going to go ahead and kick it down to the thymus. Thymus. All right. And because we're in the thymus, we're going to go ahead and become mature. It's called maturation. Process or condition of maturing. Maturation, something I will never, ever do. I'm never going to mature. I want to be a kid for the rest of my life. I want to play in the woods. I want to pick up salamanders. Yeah. I want to build mud castles. Kid. So, maturation, to become mature. Now, It doesn't mean they're immunocompetent yet. It just means that they're mature. They still have to become immunocompetent. That means they still have to be tested. They still have to be tested. Okay? So there you go. Immunosurveillance, NK, antibody-mediated humoral fluid. Okay? Antibodies. So we have B cells to plasma cells to antibodies, and they're going to circulate around in the blood. That is not hand-to-hand combat. It is not hand-to-hand combat. Now, cell-mediated, on the other hand, it's all about hand-to-hand combat. Notice here, here's an abnormal cell, here's a cytotoxic T, boom, we attack it, it's dead. Kerpow, hand-to-hand. The antibodies are just going to glom onto it. Okay? T and B cells migrate throughout the body to defend peripheral tissues. Retaining their ability to divide is essential to the immune system function. So basically what's going to happen, and you know what, I'll switch up people here so that I don't ruin her arm and her arm and her arm, okay? But you have to think about this, okay? So when a T cell gets a chunk of an antigen, okay, a foreign antigen. When it gets a chunk of a foreign antigen, you know what it's going to do? I got it. Split, and keep multiplying. That means that that one chunk of antigen said, go ahead and start splitting up, differentiating into additional cells. And each one of those has a piece of that antigen. So now they can go around and say, does this antigen belong to you? And when a foreign cell or one of our own cells say, look, I've got the antigen, we attack them. Okay? We literally attack them. So imagine this, another cell, a macrophage or dendritic cell says, hey Phil, look what I found. And I'm a T cell. Okay? She's going to present it to me, and I'm going to go, oh, wow. Bing. That matches. Anything that's blue, I'm going to kill. Anything. But then I'm going to multiply, and every single one of me that's multiplied is going to have this. And if it matches up to a blue pen, we're going to attack it. And that's how we defeat foreign pathogens. Foreign pathogens have an antigen on them, and once we have that antigen, we can hunt them all down. All of them. Okay? So, differentiation. B cells differentiate, okay, with exposure to a hormone called cytokine interleukin 7. Cytokine interleukin 7. Now remember, there's going to be a bucket load of cytokines, interleukins, so make sure you start making a little list of them. I've got an interleukin 7, I've got all these different interleukins. And then it says T cells differentiate with exposure to several thymic hormones. Okay? Now, lymphoid tissue, connective tissue, dominated by lymphocytes. Lymphoid nodules, areolar tissue with densely packed lymphocytes. Germinal centers contains dividing lymphocytes. Well, think about this. If you get sick and we start dividing in here, what happens to these nodes? They swell up. But you have to be exposed to it. If you're never exposed to it, they're not going to swell up. You have to be exposed to it. You have to come in contact with it. Oh my gosh. Tonsils. Tonsils. Well, they're part of the lymphatic system. Yes, they are. Okay? They are part of our immune system, and unbelievably, they can become so infected that they're always swollen. Always swollen. And so it becomes this lovely word you've probably heard 100,000 times, tonsillitis. And if it continues and we can't get it under control, what do they do with your tonsils? They remove them. Now, does it hurt your immune system? No. But what it does is it says, okay, if they're going to keep getting infected and keep getting infected and keep getting infected, we're just going to get rid of them. Because then we don't have to worry about it anymore. Okay, some people still have their tonsils. Peoples, who has their tonsils? About half of you. The rest of you, Sorry. Okay, so what is it? Well, it's lymphoid nodules. Okay, remember we're going to have lymphocytes circulating around. We're going to be defending against different things. Notice it does say intestinal lumen, mucous membrane. Well, guess what? Mucus is a barrier. Saliva is a barrier. Acid mantle is a barrier. You actually have acid, a certain amount of acid, pH, in your mouth. Okay? So unless you have like a really big open wound in your mouth, okay, like you bite the side of your cheek when you're eating something really tasty, you guys know what I'm talking about. You're like, oh, it's hanging there and you're tonguing it for like 5 days. Yeah. So unless you have a huge problem there, guess what? You've got some massive defenses going on here. Lysozyme going on in there, okay? So eating stuff isn't a big deal. When you see a kid picking up something and eating it, that's okay. Okay? That's okay. Yeah. I know you're thinking, no, it's not okay. Yeah, it is. You got a lot of protective things. Now, if they're sticking it into their nose and their eyes and their ears, that's not okay. Keep that stuff under control. Okay, so underlying connective tissue, aggregated lymphoid nodules, distribution of lymphoid nodules, well, lymph nodes. Lymph nodes, and what did I say about lymph nodes? You needed to know every single thing about lymph nodes. You need to know it. Whoop, let me back up. There are some respiratory tract tonsils. Yay. Those are going to defend us there. Obviously, you're breathing. It's not like you're holding your breath forever. You're breathing. Okay? And stuff's coming in. We have to stop it before it gets into your respiratory. Along the digestive, urinary, and reproductive tracts, we've got to protect you. Okay? Remember, anything that leads to the outside has the potential of becoming infected. Anything. Ears, nose, eyes, urethra, anus, all of that, vagina, all of that has to actually have some type of protection. We're going to have lymph nodes and lymphoid nodules around those areas to protect it, tonsils to protect them. Okay, but the big one that I want you guys to focus on is the lymph nodes. So MALT, we briefly brought that up, but it's lymphoid tissue associated with digestive system. We'll bring it up a little bit more when we're in the digestive system and why it helps us. Okay? The appendix, vermiform appendix, contains a mass of fused lymphoid nodules. Okay? And there is speculation, notice I'm saying speculation, that in some cases it was our primary means for protection. Okay? In the digestive tract, we do know that if it becomes inflamed, it will burst. Appendicitis. Okay? And people will have them removed. So there are 5 tonsils. You just need to know that we have tonsils. Okay? And their location. You need to know that we have them in their location. The wall of the pharynx. Okay? So, and I believe there's an image in your lab manual and in your book of where they're at. So please make sure you know where they're at. Okay, lymphoid organs, well, lymph nodes. Now, we are going to talk about the thymus and the spleen very little, but mainly the lymph nodes. We'll put all our time in the lymph nodes because they're kind of the most important thing. Oh my gosh, and here we go, lymph nodes. Okay? So, trabeculae, wow, that sounds familiar. Okay, bundles of collagen fibers extend from the capsule into the interior lymph node. Okay, let's do this. Yeah. And I know you're probably wondering why I'm putting so much effort in drawing this like this, and that's because this is the key to a lymph node. What are these things that I keep putting inside here? Valves. And they are one-way valves. They're one-way valves, which means we have 1, 2, 3, 4, 5 over here, but only 2 there. What does that mean? 5 and 2. We have 5 in and 2 out. What does that mean? 5 in and 2 out. Well, if you had 5 to 5, wouldn't that be the same amount in and the same amount out? But we have 5 in and 2 out. So what does that mean?
More in, less out.
More in, less out. If we have more going in than we have less coming out, what's happening? Yeah, it's slowing down. It's becoming stagnant. Instead of flowing equally, we have all this coming in and then boom, it slows down. It slows down inside of here. Almost to a dead stop because we have 5 in and 2 out. It slows down. Why would it be an advantage to have all that fluid, that lymph fluid, slow down in there? So we can take a look at what's going on in there. So we can see what foreign pathogens in there. If we need to activate our immune system. Yeah. It basically says, you know what, if this is a surveillance site, let's slow it down so slow that we can take a look at it and figure out if something's wrong. So, hilum, a shallow indentation of blood vessels and nerves, reach the lymph node. A shallow indentation. Okay? A shallow indentation. Trabeculae found pretty much inside. Okay? Extend from the capsule into the interior of the lymph node. So I haven't drawn the inside yet. Okay, I'm kind of keeping that. Then we have afferent. Afferent lymphatics carry lymph into efferent. Lets it go out. Recall note, what are the different names for input and output? There we go. Afferent, efferent, input, output. In fact, I believe that was even used. That was used in the heart. Okay? Now wow, that's pretty cool. That's awesome. That's phenomenal. That's great. That's beautiful. That's amazing. That's the lymph node. Every single detail of the lymph node. Now, do we have stuff going in? Yes. Do we have cortex? What does cortex mean? Outer husk. Unbelievably, we have what's called a deep cortex. Notice there's T cells. Deep cortex. Deep means within inside. Deep, right? This is superficial. Inside would be deep. A deep cortex, and this deep cortex has T cells in it. The outer cortex has B cells in it. We do have a medullary sinus. You guys see that? It's inside. It's deep. It's not a cortex. Inside the medullary cord, we have B cells and plasma cells. B cells and plasma cells. So for every aspect of this, now the trabeculae is this stuff. See this sticking in here, 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 here. That's all trabeculae, kind of sticking in. Is it funneling it? Is it funneling it to one area? It is. It's funneling it to the center. What does it have to go through? Has to go past B cells, has to go past T cells, and then again has to go past B and plasma cells. So, is this a good surveillance method? Is this a good way to see everything that's coming in? We have a 5-to-2 ratio. We have a funnel system that funnels into the inside. We have layers of B and T cells to actually survey the lymph node and tell us if there's something in there, to survey it. Now, what would that be like in this classroom? Well, here's what it would be like. We had 5 doors that only swung in. Okay, you couldn't go back out. 5 doors on the back, 1 door right here. And you had an instructor here, 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 and then instructors on the outside. Would that be enough to filter all the students that came through? Yeah, we're on the outside. You have to find your way through no matter what. All of you could come in the 5 doors, but could everybody leave out that door? No, which means it's going to slow it down, which we could take a look and find out what's going on. And that's what's happening in the lymph node. We do have that efferent vessel. Notice there are valves. There are valves. Afferent vessel right here with valves. Here, valves there. And then look at our valves going out. We just scoot right out. If you pass the test, you just leave. If you don't pass the test, dearie doe. Now, here's the aha moment for all of you. Okay? Let me come over here, and I'll just ask one of you, go in front of this camera here for a second. Let's go with, why not, Lucy. Look like you're waking up a little bit. Okay? This right here is the deep cortex, and it has T cells. Okay, and let's say there's a T cell right here, and a pathogen comes in, and we see it. And it happens to be the pathogen that's going to activate us, right? The antigen works perfectly, everything matches up perfectly, we see it, we match up, and then we start to multiply, right here. And then we multiply, and multiply, and multiply, and multiply, and keep multiplying. Now, some of us can get out, but for the most part, we keep multiplying. What happens to this lymph node? Yeah, it swells up. It gets huge. So it is no surprise that when you get influenza B, the flu, what do? Oh, I'm sick. My nodes are swollen. Right? Yeah. Now, let that resonate for a second. One lymph node, one pathogen happens to be the right one, and we start multiplying. Yeah. It's no wonder our lymph nodes swell up like there's no tomorrow. Now, is it always one pathogen to one T cell? No. It's millions of pathogens to one T cell until that T cell starts multiplying. So it's not like, okay, it's going to take forever for 1-to-1. No, there are millions of pathogens floating around, and guess what's going to happen? They're going to meet up with that T cell and B cell, and they're going to start multiplying. The B cell is going to become a plasma cell and shoot out a bunch of antibodies, and the T cell is just going to go around and start picking things off, because it's hand-to-hand combat. Questions? I know it's early, but it's a good early. Any questions? This is why I get so excited about the immune system. I know you guys are totally excited because you're just sitting there going. Go ahead.
So once the T cells multiply,
B cells are going to multiply too, but they're going to become plasma cells. So they're both going to get activated. B and T cells going to get activated by that one pathogen. Then they're going to multiply. B cells will become plasma cells and create antibodies. T cells will just multiply into more T cells, but each one of them will set aside a memory cell. Any other questions?
What happens when your body gets something it can't fight off? Like, what's the process?
Okay, so here's the big one. Either it's moving so fast that we can't, and that's what your guys' surprise is today. That's what your surprise is. It's so awesome. It's moving so fast that your body, it can't find that T cell. So it's multiplying so fast that we can't keep up with it. And that's what's happening. We can't fight it off. When they say you can't fight it off, it means that it's moving way too fast. Way too fast. And the macrophages can only do so much. Dendritic cells can only do so much. You have to activate that T cell and the B cell. And for the biggest majority of everything, they activate just like that. Everything's good to go. You don't even know you're getting it. Okay, and remember, time is not on your side. Time is not on your side. Now, I know the Rolling Stones say it is, but it's not. Okay? Any other questions? All right, about 5 more minutes, and then we'll take a break and come back for our surprise. All right, so this is going deep. It's actually going deep. It's actually telling you about where things are found, what they do, dividing B cells, dendritic cells. Now, you've heard me say macrophages and dendritic cells. Macrophages and dendritic cells, both of them are what we call antigen-presenting cells. Antigen-presenting cells. So, because a macrophage can go, wow, you don't look familiar. Gobble, 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 eat up a foreign pathogen and go like this and present that antigen to a T cell and a B cell. Okay? So dendritic cells and macrophages both are antigen-presenting cells. And B cells are too, but we'll get to that a little bit later. Now, lymph flow flows through lymph nodes in a network of sinuses, okay, through the outer cortex, through the deep cortex, through the core medulla. Now, keep in mind, please, even though I'm reading over this fast, macrophages, dendritic cells, B cells, T cells, and B cells. Now, I just said macrophages and dendritic cells are antigen presenting. Who are they going to present it to? B and T cells. They're going to present that antigen, that foreign antigen, to a B and T cell. Lymph node function to filter. It purifies lymph before returning to venous circulation, and then removes, here we go, debris, formerly known as debris for those people, okay? Pathogens, disease-causing, disease-generating, and then 99% of antigens. Well, if we have macrophages and dendritic cells in there, and they're antigen-presenting cells, don't you think they're going to get rid of all of the antigens? Yeah. So that's their primary function. Primary function right there. Now, antigen presentation. This is where we're actually going to present the antigen. First step in the immune response. First step. Very first step in the immune response. Extracted antigens are presented to lymphocytes or attached to dendritic cells to stimulate lymphocytes. Antigen presentation. So again, this is a foreign antigen right here. This is a foreign antigen. I'm a macrophage. I gobble it up, I eat it, I process it, and then I stick this out. Does this still represent this? It does. And then what I do is I go around, does this belong to you? No, no. I go around, oh, it does, blue pen, belongs to her. And she happens to be a T cell. So then she starts to multiply and goes and finds every single antigen that looks like this and destroys it. Okay? I don't really do anything, I just give it to her. She multiplies with this and finds every single blue pen out there and destroys them. And when they say presentation, they mean it. The first presentation of that is to go and find the T and B cell. Activate that T and B cell. We have to activate them. Because once she's activated, man, look out. She is crazy. Crazy. In fact, I saw her the other day out in the parking lot. Someone took her spot, and she... Man, what a T cell. Craziness. And then out of nowhere, all of her clones, her duplicates, duplicate, all showed up and took the spot back. It was amazing. It really was. I should have filmed it. It was super amazing. Okay? Yeah. So antigen presentation. Phenomenal. How our immune system works. Lymphatic functions. Well, lymphoid tissue and lymph nodes distribute to monitor peripheral infections, respond before infection reaches vital organs. So So we're actually trying to catch it before it gets out of control. Lymph nodes of gut, trachea, lungs, and thoracic ducts protect against pathogens in digestive and respiratory systems. So where do we get the most of our sicknesses? Right here. Just breathing in. You walk into an elevator, someone does, everybody's sick in that elevator now. You're done. Holding your breath doesn't cut it. I try. I do. I'm like, for like 13 floors, and then I run to the bathroom and I put my face in water, and I still get sick. It just doesn't work. Okay? All right, so we're going to stop right there. Lymph node glands. We're going to stop right there. Go ahead and take a 5 to 7 minute break, please.